Hello guys, welcome to another video in the theories of coding. Today we are going to do the problem which is called count inversions. So you are given an array and inversion count indicates how far the array is from being sorted. If array is already sorted, inversion count is 0. If an array is sorted in reverse order, then the inversion count is the maximum. Formally, two elements form an inversion if a of I is greater than a of j and I is less than j. Okay, so let's try to take an example to understand this better. Okay, let's say we are given some random array, something like this. Okay, something like this. Let me take 6 also here. Okay, how many inversions are there in this? What are inversions first of all? For example, pick two elements, right? 6 and 4. 6 is greater than 4, right? So that means we have one inversion. Okay, so whenever the left side element is greater than an element which is present on the right side. Why am I saying this element is left? It comes before, right? The index of this is 0 and the index of this element is 3. So 0 is smaller than 3 but 6 is greater than 4. So whenever an element that is appearing on left side is having a value greater than the element appearing on right side, it is going to be an inversion. Okay, so how many inversions are there in this array? See, let's start with 6. How many inversions are possible taking 6 as the element? 6 is greater than all the elements, right? 6 is greater than all the elements. It will form inversion pairs with all the elements, right? 6 is greater than 3, 6 is greater than 5, 6 is greater than 4, 6 is greater than 1, 6 is greater than 2. How many inversions are there with 6 as one of the elements? 1, 2, 3, 4, 5. 5 inversions. Okay, 5 inversions with 6 as the element. How many inversions are there with 3? Now you see 3 is greater than 1 and 3 is greater than 2, right? So how many inversions are there? 2 inversions. Okay, let's go to the next element. Next we have 5. How many inversions are there with 5? 5 is greater than 4, 1, 2. So there are 3 inversions, right? Okay, let us go to the next value. Next we have 4. There are 2 inversions. Okay, next we have 1. Now 1 is not greater than any element on the right side. So no inversion, right? Next we have 2. There are no elements to the right side. So these are the total number of inversions. 5 plus 2 is 7. 7 plus 3 is 10. 10 plus 2 is 12. Okay. So this is the technique to find out, right? One simple algorithm is the algorithm which will be of O of n square complexity. Just pick one element, iterate over the entire array, find out it is greater than which of the elements. It's greater than all these elements, so just add 5 to the answer and so on. Okay, this is one of the technique. Do for all the elements. Okay, that will be O of n square. Now let's try to reduce the complexity. So to solve this problem in a better time complexity, we use a beautiful algorithm that will help us convert it to O of n log n. Okay. So the algorithm is simple, right? So what you do, you try to take parts by parts. Okay, let's say we take this part and let's say we take this part. Okay, now we try to find out inversions here. Okay, so what we do, we again break it into two parts. So we have 6 3 and then we have 5. Okay, and then we have 4 1 here and then we have 2. Okay, now let's see that we have 6. So we have 6 here, we have 3. We again break it into two parts till we reach one element. Okay, so I am breaking it into two parts. Now okay, let's say that I were to note the inversions. Can I note the inversions easily from here? See, now when I have broken it into base cases, right, when I am combining the base cases, I can easily calculate inversions. Okay, why can I calculate inversions? Because see, I know that whichever part I took left, that is the left side part, and whichever part I have right, that is the right side part. That means left part is coming before the right part. So if an element in the left side is greater than this element, that means there is an inversion. Okay, so in this case 6 is greater than 3. That means there is one inversion, right? There is one inversion. Now let us combine these two parts. When we combine these two parts, right, I will sort them and return them. So I will make them 3 6 and I will return them. Okay, I will sort and return them. Now I will see this part, right? When I see this part, okay, now I have 3 6 and I have 5. Okay, why did I sort and return? Because see, I need to use one beautiful trick here. See, if I have 5 on the right side and if I have 3 6 on the left side. Okay, let me write it properly. I have sorted 3 6 and I have written, and on the right side I have 5. Okay, now I am trying to find out the number of inversions here. See, the order of element doesn't matter. What matters is that there is an element 6 that is coming before 5. Okay, but right now we have these two parts of the array. We are seeing 3 and 5. Okay, 3 is smaller than 5. 3 cannot be, an inversion pair for 5. So what we'll do, we'll just move this pointer and we'll come here. Okay, so in this case we have 6 and we have 5. Okay, so now 6 is an inversion for 5 because 6 is greater than 5, right? So we have found one inversion. So now we have found one inversion. Now we'll again sort the array and we'll return. So this algorithm becomes simple now. So we have sorted it and we have merged it to 356 and now we'll return 356. Okay, so now this part of the array becomes 356. Okay, now let us see this part of the array. Okay, so till now we have got one inversion. What was that inversion? That inversion was 6, 5. Okay, and we had one more inversion which was here 6, 3. So we also have 6, 3. Okay, now let us go to the right part of the array. In the right part of the array, okay, we broke it into pieces like this, 4, 1 and 2. 4 we again split to 4 and 1. Why did we do this? See, it's very easy to note inversion. We have one inversion here, 4, 1. 4 is greater than 1. 4 is coming before 1, but 4 is greater than 1. So we have one more inversion, 4, 1. Okay, so we can add it to our inversion list. Okay. Now let us merge it, and while merging we will return the sorted part, 1, 4, and then we will return 2. Okay. Why are we doing this? So that it's easy to compare. Okay, let me write it. So we have 1, 4 and we have 2. Okay. Now I know 1 can never be an inversion for 2. 1 is smaller than 2. So we'll just move the pointer. We'll see here. We'll see 4 and 2, right? We'll see 4 and 2. 4 is an inversion for 2 because 4 is greater than 2. So we have found one more inversion. Okay. And now we will merge these two parts and we'll return. So what will the array be? Array will be 1, 2, 4. Okay. Array will be 1, 2, 4. So we have found one more inversion which was 4, 2, right? 4, 2 was one more inversion. Okay, now we have the final array 3, 5, 6, 1, 2, 4. Let us see this example. We have 3, 5, 6, we have 1, 2, 4. Okay. Now what we are going to do? We are going to again find the inversions in this case. See, order doesn't matter here. It just matters that element is coming before, right? Suppose 3 is definitely coming before 1. We didn't change that. Even though we shuffled, right? See, the initial array was something like this. 6, 3, 5, 4, 1, 2, something like this. Okay, but this part elements have got shuffled, this part elements have got shuffled, but it doesn't matter. If there is an inversion between 6 and 4, 6 will anyway remain in this part, 4 will anyway remain in this part. We will anyway find it out. Okay, but if we have sorted it, it will be very easy to find the inversions. Okay, how is it very easy? See, we have 1 and we have 3 here. So in this case, 3 is an inversion for 1, right? 3 is an inversion for 1. Okay, because 3 is going to be greater than 1. Okay, so if 3 is greater than 1, do we need to check all these elements? 5, 6, we need not even check all the elements. If 3 is greater than 1, definitely 5 will be greater than 1, definitely 6 will be greater than 1. So when we are comparing 3 and 1, we can add 3 inversions directly because 3 is greater than 1, 5 is greater than 1, 6 is greater than 1. We have got 3 new inversions directly. Okay, so it's very easy to compare inversions if both the parts are sorted, right? So we have got 3, 1, 5, 1, 6, 1, and we have just added 3 new inversions. Okay, now let us go to the next part. Now next, which should we compare? For 1 we already know there are 3 inversions. Let us change this pointer and look here. Now we will compare for 3 and 2 how many inversions are there. Now see, again 3 is greater than 2. What does that mean? If 3 is greater than 2, we have 5 which is sorted, right? So 5 is also greater than 2, 6 is also greater than 2 because this array is sorted. All elements are bigger, right? So we again found 3 inversions directly. We need not even compare and iterate through everything. We know that we have 3 inversions, right? So we found 3 new inversions. What are the 3 new inversions? 3, 2, 5, 2, 6, 2. Okay, we found 3 new inversions. Okay, now let's go ahead. So what is the next pointer that we will visit? Next we will visit 4. Okay, now we have to compare 3 and 4. Now 3 is not an inversion for 4 because 3 is less than 4. Okay, so in this case 3 is not an inversion. So now for the first time we will move this pointer. Okay? So we will move this pointer. Now we will compare 5 and 4. Now 5 is an inversion for 4 because 5 is greater than 4. So obviously 6 will also be greater than 4. We need not even check. So at this point we have found 2 inversions. Okay, what are the 2 inversions? 5, 4 and 6, 4, right? So at this point we found 2 inversions, 5, 4 and 6, 4. Okay, and we have got 2 new inversions. Okay, now let us. Okay, so what is the total final number of inversions? So we have got all the inversions. These are the final number of inversions. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 3, 7, 7 plus 3, 10, 10 plus 2, 12. We have got 12 inversions. Okay. Now let us go forward to see the code of this. So basically what algorithm were we using here? We were using the algorithm merge sort. We are basically breaking the array into smaller parts. So we have a whole array, we are breaking it into half and half parts. Again we are breaking it into smaller parts, and then we are trying to merge the smaller parts back into bigger parts, and we are sorting it. While sorting, we'll just count the inversions also. Okay, so we'll use the same code for merge sort, we'll just add one additional line. Okay, so we are using the same merge sort code, this merge sort. So what we do in merge sort, we take left part of the array. Okay, if we find the middle position first of all, left part of the array will be from low till mid, and we take right part will be mid plus 1 till high. We have left part, we have right part. If we have only one element, we can simply return the single element. Otherwise, we'll keep recursively iterating. We'll keep calling this function again and again. We'll get the left part, we'll get the right part. We'll merge both the left and right parts. Okay, so we are just merging both the left and right parts. While merging, we'll also count the inversions. Okay, so while merging, so this is a simple code for merge sort. So if left of I is less than equal to right of j. Okay, so in that case, if this is the smaller element, what we'll do, we will merge it and put it in the answer array, and we'll move the I pointer. If j is the smaller element, then in that case we'll shift the j pointer. Okay, now while we are doing this, right, whenever there is an element on the left side that is greater than right side, right, if j means the right side is the smaller element, that means left element is larger, so we'll also count the inversions. We are counting the inversions, that's what we are doing. This is the only additional line. If I remove this line, right, the entire code is a merge sort code only. This is the only additional line. Okay, and we have this. At last, if there are remaining elements, we will also put them in the answer vector, and we will return the answer. Okay. Same merge sort code, and finally we can return the count. So let's submit and see if this is working. So this is working. That's it. Thank you for being patient and listening.